Hey everyone. Okay, so today we're going to tackle radical multiplication. Yesterday, just to recap, we dealt with addition and subtraction of radicals. And one of the things that, actually there's kind of two things I want to mention on that. First, I said, hey, dealing with radicals is a lot like dealing with polynomials as far as the rules go, right? And yesterday we saw that when I said, hey, what's a 3x plus a 7x? Well, that's a 10x. Those are like terms, so we can just put them together. Okay, the x's don't change. It's like 3 apples plus 7 apples equals 10 apples. And that worked the same for radicals. The radicand had to be the same. So if I had 3 root 2's and I had 7 root 2's, that would give me 10 root 2's. Okay, so kind of the rules that we did with polynomials, they parallel themselves with radicals, okay? With multiplication, let's go back to here for a second and we would say, okay, how do you multiply 3x times 7x? So if I went 3x times 7x like that, well, you would tell me, hey, Hill, you're going to multiply the 3 and the 7 together, and you're going to multiply the x and the x together. So 3 times 7 is 21, and x times x is x squared. Okay? There is a similar thing happening with radicals. Now, I want you to notice I didn't do the same one here. I did that purposefully. Because I want you to see a process without showing you another property that I want to deal with later. So 3 times 7 is 21. And then what you do is you multiply the insides together. So you have root 2 times root 6. Well, that'll be 2 times 6, which is root 12. Okay, so I end up with 21 root 12. And then, of course, we would look at this and we would say, okay, can I simplify that at all? Can I find a perfect square factor of 12? Well, yes, I can. 4 times 3, and the 4 would come out and be a 2, right? So all the simplification things that we've talked about, we would continue to talk about as we progress here, okay? Really, that's your entire lesson. See ya. No, we'll go a little slower now, but that's kind of what we're doing today, okay? So in order to multiply radicals, only the root index has to be the same. Okay, so when we were adding or subtracting, the radicand had to be the same and all the variables on the outside had to be the same. Here, only the root index has to be the same. Okay, and we can always verify our answers using our calculator, right? You take the question, plug it into your calculator, you take the answer, plug it into your calculator, and although they're both going to be decimals, they should give you the same decimal. Okay, so in general, what we say is a nth root of b times c nth root of d equals ac. So we're just multiplying a and c together, okay, times the nth root of bd, which is multiplying the radicands together, okay? And that works as long as n is a natural number and a, b, c, and d are all real numbers. And again, we also have to talk about restrictions, just like we have been doing the last couple of lessons. If n is even, so if the root index is even, then you have to remember that b would be greater than or equal to 0, and d would be greater than or equal to 0 as well, okay? All right, so let's try it. Simplify the following expressions, state any restrictions on the variables. Well, these first couple that we're doing, kind of just to get you going and get you comfortable, they don't have variables, so we don't have to talk about restrictions. Okay, so I really have two options here. I can look at this and say, hey, I should simplify root 20 first. Or maybe some of you want to say, hey, no, I'm going to multiply the 6 and the 20 together, and then I'm going to work on simplification. You know what? It totally doesn't matter. Whatever you want to do, you go ahead. Whatever fills that bucket of yours. I went and said, okay, 3 times 5 is 15, and 6 times 20 is 120. So I have the outside numbers multiplied together. I have the inside numbers multiplied together. 3 times 5 is 15. Root 6 times root 20 is root 120, because 6 times 20 is 120. Okay, now I want to work on simplifying that 120. So I'm thinking, okay, what are my perfect square factors of 120? I believe I can do 4 times 30 there. So I'm gonna break my 120 into root 4 and root 30. And then I ask myself, what do I know? Okay, this is all very similar to what I have done in simplification. What do I know? I know that the root of 4 is 2. So that becomes 15 times 2, which is 30. So my final answer there will be 30 root 30. Okay, 30 root 30. Awesome. Okay, root 13 times root 13. Now this is the one I was avoiding up here with that root 2 times root 2. Root 13 times root 13. What I want you to notice there is it's 13. Okay, it's root 13 squared. Let me just put the answer there for a second. It's root 13 squared. Okay, so there's a couple different ways you could think about this. You could say, oh, okay, well, that is the root of 169. Sure it is, because 13 times 13 is 169, but the root of 169 is 13, okay? So you would never answer root 169. You would say that is the whole natural number 13. It's not root 13, it's 13, okay? I'm trying to be really, really clear about that, because this is something that kids mix up all the time. They think their answer has to have a root. Well, no, it doesn't have to have a root if the answer is an actual number. Okay. The other way maybe you want to look at that is you want to say, hey, it's root 13 squared. Okay. And then you want to think about the fact that the root index and the exponent of 2 are inverse operations of each other. So they undo each other and just leave us with the 13. Okay. All right. Oh, this looks fun. Hey, you totally want to try this. Okay. It's just the distribution law. Okay. So we're going to go this guy times here and this guy times here. So negative 2 times 4 is negative 8. 12 times 2 is 24. So that first term I'm going to be looking at would be negative 8 cube root 24. Don't drop your cubes, right? Or your cube roots. The root index has to stay the same the whole way through. Then the outside guy with the last guy, I've got negative 2 times negative 3 is positive 6. 12 times 3 is 36. So that's going to be plus 6 cube root of 36. Okay, now I'm looking at what can I simplify? Do I know a perfect cube factor of 24? Remember, you're looking for perfect cubes now, not perfect squares. I do. 8 times 3 is 24. So I can break that into the cube root of 8 times the cube root of 3. Nothing I can do with the 36. Then I know that the cube root of 8 is 2. So this will simplify into negative 16. Right, negative 8 times 2, cube root 3 plus 6 cube root 36. Okay, negative 16 cube root 3 plus 6 cube root 36. Isn't this fun? Okay, a couple things here that we want to talk about. Every question has a story. Okay, but what we want to think about is the following. First of all, it's 2 binomials being multiplied together. So I know I need to go first, outside, inside, last. Those guys multiplied together, those guys multiplied together, insides, and then lasts. Okay. So let's just go through that step by step. So 4 root 5 times 4 root 5. Well, 4 times 4 is 16. Root 5 times root 5 is 5. So that's going to give me 16 times 5. Then the outsides, I'll have 8 root 5. 4 times 2 is 8. And then root 5 times essentially root 1, right? Because there is nothing there. So that'd just be 8 root 5. And then here I've got negative 8 root 5. And then here I've got negative 4. Okay, so now I can simplify this to be 16 times 5 is 80. I want you to notice my 8 root 5s and my negative 8 root 5s. I guess I shouldn't have pluralized that, but 8 root 5 minus 8 root 5 is nothing, so it's gone. So I end up with 80 minus 4, which is 76. Okay, 80 minus 4 is 76. Now these guys are special, like my mama told me I was. I just want to switch colors here for a second. These guys here say the same thing with opposite signs in the middle. Okay, there's a word for that, and the word is that they're conjugates. Okay, conjugates are the same binomial where one gets added and one gets subtracted. If you think back to 10C, conjugates were actually the factors of a difference of squares. Okay, do you remember us talking about a squared minus b squared will always factor into a plus b times a minus b. Those are the conjugates, a plus b and a minus b. Okay, so when you see that, you know that you're going to end up with essentially a squared minus b squared. So I could have just gone 4 root 5 squared, that's where the 80 comes from, minus b squared, which is 2 squared, that's where the 4 comes from. Okay, so in general, a minus b times a plus b equals a squared minus b squared. The binomials are referred to as, that should say the binomials are referred to as conjugates, okay? Awesome. Okay, now we're just gonna distribute this guy, right? This guy times here, this guy times here. What's the difference? Well, I've already asked you a question like this. What am I throwing at you? I'm throwing letters at you, okay? So now we need to think about restrictions. I'm dealing with even root indices here. And I have odd exponent on C in both places, doesn't matter as long as it's in one spot. That tells me that C has to be greater than 0. Okay, so C is greater than or equal to 0. Now I'll distribute, so I've got negative 2 times 4 is negative 8. Root 11C times root 2C is going to give me root 22C to the 4. Then I'll multiply these guys together. Negative 2 times negative 3 is positive 6. Root 11c times root 3 would give me root 33c. Okay, now I'm trying to simplify this. I'm looking for perfect square factors. There is no perfect square factor of 22 or 33, but c to the 4 is a perfect square. So c to the 4, the root of c to the 4 is c to the 2. So I can bring a c to 2 on the outside instead of having c to the 4 on the inside. Okay, so my final answer there, as long as c is greater than or equal to 0, will be negative 8c squared root 22 plus 6 root 33c. Okay. See, that wasn't so bad. All right. I have a binomial squared. Well, if you want, you can write that as 2 root 3a plus 3 root 4a times 2 root 3a plus 3 root 4a. And you can go first, outside, inside, last. Oh, my marker's dying. I hate markers that are dying. It's like one of my pet peeves. I have 2 pet peeves in life. Dying markers, actually I have 3. Dying markers, wet socks, and when kids congregate at the door before the bell rings. Those are my 3 pet peeves in life. Okay, so you could do that. You could multiply it all out. I'm not gonna, because if you remember, we squared a ton of binomials in quadratics. And do you remember what we kept saying? We kept saying square the first, double the product, square the last. I'm just gonna do that. I'm gonna square the first, double the product, square the last. If I square the first, here's my first. That's going to give me 4 times 3a, right? 2 squared is 4. Root 3a squared is just 3a. So 4 times 3a would be square the first. Double the product. Well, the product would be 6, 2 times 3, 6 root 12a. 6 root 12, sorry, a squared. 6 root 12a squared. If I double that, that'll be 12 root 12a squared. Okay? And then square the last. 3 squared is 9, and the root of 4a squared is 4a. So I'd have 9 times 4a there. Okay, so don't forget about your restrictions. A has to be greater than 0 here because I have an even root index and an odd exponent on a. Okay, square the first, double the product, square the last. And here we are. So I've got 4 times 3a. This is what I just said out loud, right? And we're now just seeing the visual. Plus 12 root 12a squared plus 9 times 4a. Now I've got 4 times 3a is 12a. That'll be 36a. I can put those together. 12 and 36 are 48a. And then I want to simplify this guy. 4a squared is all a perfect square there. That can come out to be 2a. And then that would leave me with root 3a. I have a 2a on the outside, so 12 times 2a would be 24a. Now, if I'm freaking you out that I said that out loud and I haven't written anything down, it's going to come. But the more you can talk yourself through this, the more you can kind of follow what I'm saying without seeing it. That means that there's connections happening in your brain. And that's what we're going for. I'm never trying to stress you out when I do that. I'm just trying to help you make those connections, okay? So now let's look at it visually. I've got my 12a, I've got my 16a. That's a mistake because 9 times 4 is definitely 36. Sorry about that. Okay, that should say 36. And then I did that, I broke my 12a squared into my 4a squared here and my root 3. Okay. So then I've got 12a plus 36a, so that's going to have to be 48a. Okay. And then I've got this guy is 2a, the square root of 4a squared is 2a. So then 2a times 12, that's where that 24a that I was talking about is coming from. Okay. So that 28 should actually be 48 because I had added 16 and 12 instead of 36 and 12. Okay, so that guy would be 48a. Oh, that was a bad 8. Okay, 48a plus 24a root cubed. Okay, I'll get that fixed in my PowerPoint, but for those of you in the video, hopefully that makes sense. Okay, good. Now, do the next question, just let me clear all that stuff off. Okay, so now we want to FOIL this just like we have. Okay, so first, outside, inside, last. Think about restrictions. C has to be greater than or equal to 0 here. I've got 5 times 2 is 10. Root C times root 3C would be root 3C squared. So that's going to be 10 root 3C squared. Then that's my outside now is -5 root C. My inside, you see my mouse there? That would be 4 root 3C. And then my last would be -2. So 10 root 3C squared minus 5 root C plus 4 root 3C minus 2. I want to take a look at that and say, is there anything I can clean up? Yes, this C squared here can come out and be a C. But other than that, I can't do anything else. There's no other simplifying to do there. Okay, so the C squared came out to be the C, and then I'm good to go there. All right. Okay, so for the last example before our word problem, we've got 4x cubed root of 54 minus 2 cubed root of 3x times the cubed root of 18x squared minus 5 cubed root of 6x cubed y to the 4. Now, the first thing I want you to notice here is this is not two binomials being multiplied together, okay? A lot of kids are gonna say, oh, I have to go this times this and this times this and this, whoops, this times this and this times this. That's not true because there's no brackets here. That would only work if those front two terms were in their own set of brackets. Okay, so actually what we're doing here is we're just going to take this -2 cubed root of 3x and we're going to distribute that into those two terms. But the 4x cubed root 54 doesn't have anything to do with anything that's being multiplied. It's just in the front. Okay, so the first thing I'm going to do is talk about restrictions. I'm dealing with cube roots here, so there are none. So I can say both x and y are members of the real family. Okay. So x is a member of the reals and y is a member of the reals. And now I'm going to do the multiplication. So I'm going to go -2 cubed root of 3x times this guy. So first of all, my 4x cubed root of 54 is just going to go as my front term. Then I'm going to have here -2. 3 times 18 is 54. X times x squared is x cubed. So that'll be -2 cubed root of 54x cubed. Then I'm going to do this one. So that's going to give me +10 when I multiply the -2 times -5. Okay, and then the 3x times the 6x cubed y to the 4 is going to give me 18x to the 4 y to the 4. Okay, so the first line I'm showing you here is just me doing that multiplication. Okay, now I want to start working on simplifying it. So the cube root of 54, I'm going to break that down into the cube root of 27 and the cube root of 2, because 54 is 27 times 2, and I know that 27 is a perfect cube, okay? Here, I'll do the same thing, 54x cubed, my perfect square, or sorry, my perfect cube portion there will be the cube root of 27x cubed, and then my leftover bit, again, will be cube root 2. And then here, I can't actually do anything with the 18, but I can take out an x cubed and a y cubed. So I will do that, okay? So now I'm asking myself, okay, what do I know? I know the cube root of 27 is 3, so that's gonna be 12x cube root 2. Here, this is gonna be 3x times 2, so that'll be negative 6x cube root 2. And then this is going to be xy, so I'll have 10xy, cube root of 18xy. Okay, now I'm asking myself, okay, is there anything I can combine? I can see this here is both of those terms are x cube root 2. So that becomes like 12 apples minus 6 apples. So I'll get 6 apples out of that. So 6x cube root 2 plus 10xy cube root of 18xy. Okay, so that'll be my final answer. All right, awesome. Okay, so let's end our time together with a word problem, because I know word problems are everybody's most favorite thing in the whole wide world. An isosceles triangle has a base of root 20 meters. Just a reminder, an isosceles triangle means that two sides are equal to each other, okay? Each of those equal sides is 3 root 7 meters in length. Determine the exact area of the triangle. So first thing I want to do is draw myself a little picture. I also want to think about root 20. I can simplify root 20, right? 20 is 4 times 5. So root 20 would be root 4 times root 5, and then the root 4 is 2. So instead of writing root 20, I'm going to write this as 2 root 5. Okay, so I've got an isosceles triangle here. I know my base is going to be 2 root 5, and both of my equal sides are 3 root 7. So I've labeled that. Now, I know that the area of a triangle is base times height divided by 2. So I need to get a height here, and I need to actually solve for the height. So remember, we've talked about this in previous lessons, but the words base and height, there has to be a 90-degree angle between them. So what I'm going to do is I'm going to drop a perpendicular line right there, and that'll be my height. Okay. Now, if that's my height, I need to find it using the Pythagorean theorem. So think this through for a second. I've got this cute little right triangle here that I'm drawing in pink, where I know the hypotenuse is 3 root 7. And I know that the base of that triangle is root 5, right? I know that that would be root 5 and that would be root 5. And that's how I get, whoops, that's how I get the 2 root 5, okay? All right, so what I'm gonna do is I'm gonna say, okay, 3 root 7 squared equals root 5 squared plus the height squared. And I'm going to solve for my height, okay? So 3 root 7 squared equals root 5 squared plus h squared. Okay, I don't think I'm hiding, but just in case my head is hiding that, I'll just hide myself for a sec. There you go, okay. Okay, so 3 root 7 squared, well, 3 squared is 9, root 7 squared is 7, so that'd be 9 times 7. Root 5 squared would just be 5. So I get 9 times 7 equals 5 plus h squared. 9 times 7 is 63, and I'll subtract 5 from both sides. So that'll give me 58 equals h squared. So then h would be the root of 58, okay? So now I know that my height is root 58, and my base is 2 root 5, okay? Height is root 58, and my base is 2 root 5. So now I know that my area will be base times height divided by 2, okay? Base times height divided by 2. So I know my base is 2 root 5 times my height, which is root 58, and then divided by 2. Now, my 2 over 2, they'll divide each other out. That'll just be a 1. So I'm really left with root 5 times root 58. 5 times 58 is 290. So I'm looking at the root of 290 meters squared. Now I would look at that and say, can I simplify that at all? But there actually is no perfect square factor of 290. So that is in its simplest form, okay? So the area of this triangle is root 290 meters squared, okay? All right, guys, you did awesome. Here is your homework for multiplication. Give yourself some time to go through it. Make sure you're checking your answers as always. And as always, make sure you come and chat with me or connect with me if you have any questions, okay? You got this. Next up, we will do division of polynomials. So I'll see you for that, okay? Take care.